Hello students, so here we are with the question 3rd of the exercise 3.2 of the chapter pair of linear equations in two variables. So the question 3rd is on comparing the ratios a1 by a2, b1 by b2 and c1 by c2, find out whether the following pair of linear equations are consistent or inconsistent. And the pair of the linear equations have been provided in part A, B, C, D and E. Before doing this question, as we know, what we have done in question 2nd of this very exercise, a1 by a2 denotes the ratio of the coefficients of x in the pair of linear equations, while b1 by b2 denotes the ratio of the coefficients of y, and c1 by c2 was the ratio of the constants of the pair of linear equations. And what have been asked in the question is to find whether or no the pair of linear equations are consistent. What the word consistent means? The word consistent means that the pair of the linear equations are solvable. Means we are able to find the solution of the pair of the linear equations. Then what is the method to say whether the pair of linear equations are consistent or inconsistent? Those pair of linear equations are said to be consistent if their ratio denotes either the pair of linear equations are intersecting, or we can say the pair of linear equations comes out to be consistent. And the pair of linear equations are said to be consistent if they are coincident. Okay, if the pair of linear equations comes out to be intersecting, or we can say comes out to be coincident, then those pair of linear equations will definitely be consistent ones. And then what pair of linear equations are said to be inconsistent? Those pair of linear equations are said to be inconsistent which are not solvable. That is, we are not able to find the solution of those pair of linear equations. And those pair of linear equations will be parallel lines. So now coming to the question, as we have done in question 2nd of this exercise, the procedure of how to find whether or no the pair of linear equations are intersecting ones, coincident ones, or parallel ones. So if we revise that concept, what it says, first of all, we will find the ratio of a1 by a2, b1 and b2, and c1 by c2. And if a1 by a2 is equals to b1 by b2, which in turn is proportional or equal to c1 by c2, then those pair of lines will be coincident lines. And if a1 by a2 is not equal to b1 by b2, then those pair of lines will be intersecting at a point. Or we can say meeting at some point. And as we know, those pair of linear equations which are intersecting or coincident are always consistent. Means solvable. And if a1 by a2 is equal to b1 by b2 but not equal to, or we can say is not proportional to c1 by c2, then those pair of linear equations are said to be parallel lines. And if pair of linear equations are parallel lines, then they have inconsistent solution. That is, we are not able to find the solution of those pair of linear equations. So keeping this concept in mind, let us do the question. So in part A, we have been provided with two pair of linear equations. So comparing them with the standard form and finding the ratio a1 by a2, b1 by b2 and c1 by c2, this ratio comes out to be equal to 3 by 2. b1 by b2 is minus 2 by 3 and c1 by c2 is equals to 5 by 7. And as a1 by a2 is not equal to b1 by b2, What it means is that these pair of linear equations are intersecting at some point, or we can say they are consistent. Now coming to the B part. Comparing the pair of the linear equations provided with the standard form and finding the ratio A1 by A2, B1 by B2 and C1 by C2. A1 by A2 is equals to 2 by 4. B1 by B2 is equals to minus 3 divided by minus 6, and C1 by C2 is equals to 8 by 9. Simplifying them, it comes out to be equal to 1 by 2, 1 by 2 and 8 by 9. A1 by A2 is equal to B1 by B2, but it is not proportional or is not equal to C1 by C2. So these pair of linear equations are said to be parallel lines, or we can say inconsistent. Now coming to the C part and finding the ratio A1 by A2, B1 by B2 and C1 by C2. A1 by A2 is 3 by 2 divided by 9. B1 by B2 is 5 by 3 divided by minus 10, and C1 by C2 is 7 by 14. Simplifying the ratios, it will be 3 by 18, 5 minus 5 by 30 and 7 by 14, or we can write it as 1 by 6 minus 1 by 6 and 1 by 2. As A1 by A2 is not equal to B1 by B2, which also is not proportional to C1 by C2, so this is the condition of intersecting lines, means the pair of linear equations are consistent. Now coming to the D part, comparing the pair of linear equations provided with the standard form and finding the ratio A1 by A2, B1 by B2 and C1 by C2, which comes out to be equal to minus 5 by 10, minus 3 by 6 and minus 11 by 22. Simplifying them, it's minus 1 by 2, minus 1 by 2 and minus 1 by 2. So A1 by A2 is equals to B1 by B2, which in turn is equal to C1 by C2. So this is a condition for the lines to be coincident, or we can say consistent pair of linear equations. Now coming to the E part, comparing the pair of linear equations with the standard form and finding the ratio A1 by A2, B1 by B2 and C1 by C2. A1 by A2 is equals to 4 by 3 divided by 2, it's 2 by 3 and 8 by 12, or we can write it as 4 by 6, 2 by 3 and 8 by 12. Simplifying them, the ratio comes out to be 2 by 3, as 2 into 2 is 4 and 2 into 3 is 6. So its ratio is 2 by 3. This ratio is also 2 by 3 and this also on simplifying comes out to be 2 by 3. A1 by A2 is equal to B1 by B2, which in turn is equals to C1 by C2. So this is the condition for the lines to be coincident. So the pair of linear equations are said to be consistent. Right. So this was all about the question 3rd of the exercise 3.2. I hope this question is clear to all of you.